I want to again remind people that we are going to make all the slides available very soon, maybe next couple of days. And hopefully there will be a recording available very soon as well. So you don't have to worry about taking notes and all that. So everything will be available. Hey, David, can you take your seat, please? I want to pick on our people. Hey, David, can you take your seat so we can get started? Okay, it's time to get started. It's my real pleasure to introduce Tom Anschutz. You heard his name from me a couple of times already. He's one of the old timers when it comes to working with us. He was also
I'm not that old.
When it comes to working with us, right?
Uh-huh.
And he was also one of the original authors of Domain 2.0 white paper. And so he has played a very important role inside AT&T as well. And really, he has been part of this CORD and residential CORD all along and has contributed at many different levels. It's good to have him come here and talk about residential CORD.
Okay, thank you, Guru. I'm honored and privileged. Is it working? Can you guys hear me all right? No? A little bit louder? How about now?
That's the song. A little bit louder now.
A little bit louder now.
Was Rachel that's not recording?
Are we good?
Oh yeah. Okay.
Shall I go? Can you hear me now? Okay, I'm assuming that means yes. So hi, I'm Tom Anschutz. I'm glad to be here, really privileged and honored. And I've got a lot of chord charts to show you in the next 10 minutes. So I know it's right after lunch and you'd really rather be napping. I sure would. But why don't we have a look at our chord in a little more detail. So the first thing we're going to do is talk about the game that's afoot. It's really about disaggregating network elements. It's a picture I've shown in the ONS in previous times. It's basically looking at our legacy vertically integrated boxes, taking them apart and figuring out how we can map them to common infrastructure. And so this is sort of the template. What we're going to do is actually look at a typical broadband access, in this case a GPON network, and we're going to look at all of the boxes that happen from end to end in that environment. If you look at the chart, and we start at the left, there's the famous broadband network gateway. This is what does subscriber management and routing. You heard Larry talk to it a little bit. Ethernet aggregation happens in the access. There is a specific PHY that's put into a GPON optical line termination device. It then gets split in a passive optical network. And finally, you get to the home where there are optical network terminators or ONTs and residential gateways or RGs, and then all the really fun stuff like IPTV, set-top boxes, and internet access for computers and voice over IP telephony. Okay, so if we walk through these boxes one by one, we're going to play that disaggregation game. The first one is the BNG. And you've probably, I'm going to go quickly through these because I think you heard a lot of this theme from Larry earlier in the day. So in the BNG, we can take this apart and we can map it to existing NFV infrastructure. There's no particular PHY or technology or something special inside a BNG that can't be executed either in the compute or in the fabric of data center infrastructure. And so that's what we do. We map the functions of BNG into the fabric switches, into subscriber management VNFs, which we call Virtual Service Gateway or VSG, and also in the SDN control and management applications, right? There's a routing VNF that Saurav described really well just in the talk before lunch. And of course, we have all of this infrastructure of servers which scale out and switches which scale out. So there's no special hardware needed in this space. The next one's even easier. It's Ethernet aggregation. And so the Ethernet boxes that we have placed in the network up until now are fairly easily mapped into the fabric that Saurav described before lunch. It scales out really well, and this is a pretty straightforward mapping. Here's where things get interesting. When we get to the optical line termination, the OLT, what we find is that almost everything can map into the servers in the fabric, but not. There is a need still to create a high volume PON MAC. So if you're looking at typical data centers, you find lots of Ethernet at different speeds and feeds and servers and switches, but not so many GPON interfaces, right? So that's what we need to create here. And so part of the thing that we did in concert or in coordination with the ARCORD project is we created a new design we brought to the Open Compute project for a scale-out PON MAC, right? As we called it, the AT&T Open GPON OLT. And this then racks and stacks in the racks just like servers do, and provides those GPON PHYs that you wouldn't have found in a typical data center. However, the box does wind up getting run very similarly to the top of rack switches that you'd find in a data center, in that, if you remember early on when Saurav showed you the typical software stack in a top of rack switch, talk about booting from ONI, loading up an operating system and providing an API an Indigo agent and so forth. That's repeated in this model. We shamelessly stole, I should say, from the top of rack switch software design common at OCP. In this case, we didn't have merchant silicon for switching and forwarding. Instead, we had GPON silicon. So we created a abstraction layer that made GPON look like Ethernet. That is, and then we put this typical agents for OpenFlow for doing flow and forwarding, and also for NetConf for doing basic management of the OLT. And then all the feature functions that you would find in an OLT, things like IGMP snooping with proxy reporting or 802.1x authentication, we kick that up as ONOS applications so that we can reuse them from one platform to the next. And of course, there's a spec there, as it is open. All right, and then lastly, the residential gateway. It was kind of very small and almost hidden on the first chart, but we have monkeyed around with the residential gateway as well. We've created an architecture where the basic capabilities of a residential gateway are largely intact, but they are well augmented by things that can be spun up in containers in the cloud. And so and there's also a desire to maybe look at what you could place on CPE in future as well. So that is running through all of those, all the different mappings from the individual elements into constructs that can be put and are put into our cord. And then some of more thoughts that we have about this sort of re-architecting come along here. So when you look at physical networks, it's really advantageous to think about physical network elements, or PNFs. It's really interesting to sort of take them apart and look at the subsystems that are within them. Many times, you can reuse those subsystems much more readily as you could the entire bundled network element. And that's kind of an important thing. And so this disaggregation also supports smaller, simpler VNFs that then become much easier to reuse and also much easier to use again. A lot of the things that are functions that are repeated in one network element after the other in a canonical architecture wind up being something you can deduplicate in this architecture. And so aggregation is one of those things. In a typical legacy broadband architecture, every node along the way does some amount of aggregation. And in this new cord architecture, most of it is done in the fabric, right? In the leaf and spine fabric. There's also an interesting thing around protocols that many times in the past, there's a need to share a sort of a state or a condition across a number of network elements, and you had to signal that state. When we get into some more details, we could go into, it's a very interesting story around how multicast is run in the ARCORD architecture. In legacy network elements, you'd have to sort of like dominoes or a daisy chain, you'd have to signal for multicast from one element to the next, and each one would have to manage its multicast tables, and then that would ripple up and ripple back as the multicast groups got sent. In the ARCORD architecture, we pick up the intent for a multicast group early on, and because the controller is quasi-centralized over a large number of network elements, there's no need to kind of daisy chain or do a dominoes effect through all these elements. It goes up to the controller. The controller knows the state of many elements at once, and then can push the right multicast replication rules or filters into many elements at once. So rethinking how the protocols work is another really interesting thing about the R-core architecture. And then the penultimate bullet here is you can think about using the architecture to attach or attack many of the operational costs that occur for operators. And one of my favorite examples in this space is ONU registration. In the before time, the text that went out to install our UVerse service would carry along what we called a butt set, which is sort of a telephony thing that they wear, you can imagine. And essentially, they would have to take the serial number from an ONU, and they would have to enter this information into our network management systems. And until they had done this, and correctly, that thing would not come up on a GPON. And when we looked at, that's something where you have errors, something that takes time, and something that they probably don't really enjoy doing in the first place. Well, in the R-core architecture, we were able to say, look, let's make the normal case work, and then go look for aberrant cases afterwards. So instead of having to pre-register an ONU before it can attach to a GPON, we'll just accept them. The ONU attaches, we see it trying to register on the PON, we collect its serial number, and we say, okay, that's probably the right thing to do. And then we'll wait for the security folks and the whatnot to say, yeah, that's a good one or that's a bad one, because we can do that after the fact and then say, flick it off of the GPON if it was a rogue unit or what have you. And so in this new model, a technician just installs an ONU, doesn't have to pick up any special provisioning or doesn't have to spend extra time in that sort of way. And so I think that's just the tip of the iceberg. There's frankly, I think, a lot more that can be done in an operations space to streamline how networks work in the context of the carrier network. Okay, and then finally, and I think Al had pointed out this in his keynote, that scaling is great, and we love to talk about scale out, right? But many times, the harder problem is scale down. So if I want to deploy something in an outside plant, or I want to have it in a very small office, and I only really need one or two, let's say, servers for the compute portion, do I really want to have the 3 or 4 other servers that are needed there to set up OpenStack and the ONOS cluster and so forth? So you've heard us say this once or twice, and in the breakout session we'll say it some more. We think that there's a sort of a real sweet spot to being able to do what we call write and light for CORD in general, and its ability to scale down and to federate and not just have everything in just one location. All right, and so pulling this all back together from the original theme, we have all of those network elements that came from the before time, and we've mapped them all into the CORD pod, into the various blue boxes that you see in front of you, where the aggregation goes into the fabric, the BNG is split up into the virtual router and partly into the virtual service gateway, or VSG. The residential gateway is augmented with capabilities from the VSG, and the access, the OLT, is split up into a new PHY device, an open OLT that's in the bottom left corner of your CORD pod, and also 2 software pieces. There's a driver, a VOLT stack that provides your OpenFlow and NetConf, and then there's the apps on top of ONOS that provide the feature functions that actually turn it into a virtual networking function. Okay, and so that all plays together. This chart shows it without that complex before time mapping, and you can see how you'd easily augment the work that had happened so far for GPON by adding G.fast, which occurs usually with GPON backhaul and with a DPU, a distribution point unit that's typically placed in a multi-dwelling unit or an outside plant, and simple CPE for that technology. Okay, so So what is in RCord? It's both hardware and software, all of which is open. We've done, I think, a really excellent job in RCord. There's only tiniest amount of proprietary software that's there, and it's at a very, very low level in the stack. It's, we have a bill of materials for people to build on a development or test system, and I'm sure people will talk a lot more about that later in the day. It's a distribution of ONOS, XOS, OpenStack, and the example applications that actually, turn the platform into one of the example applications, the R in RCord, if you will. And of course, other people will talk about the other variations. The good news, and I think this came from earlier, China Unicom was talking about, it's not just one kind of instantiation we're interested in. We very much want this idea of a platform that can host an RCord and an MCord and an eCord and I don't know what yet cord, all on the same platform without having to redo it to a great extent. That's really important. And then because it's SDN, there is also this ability to slice and think about things like multi-carrier access or allowing third parties to host applications and services on the infrastructure as part of the services and monetization for putting it in place in the first place. Okay, and then lastly, so what are the value propositions we see from going into RCord as opposed to what we did before? So the one thing is we think it expands the supplier ecosystem. Because they're smaller components, because a lot of this is new, it opens doors for startups, it opens doors for non-traditional kinds of vendors, there's new service integration opportunity. There's a lot of opportunity here because we've shaken up things a little bit, right? It's espousing open source and open spec. So we didn't have to make the kind of hard choices in developing the original RCord, which gave any particular vendor a sort of a leg up in the overall picture. So it's all open everything. We believe it really substantially meets our primary need of shortening our time to market by being able to develop capabilities and services very quickly. There is this really new exciting thing. I think Al Blackburn's last point was it's fun, right? That the whole business of collaborating as opposed to the way we used to do things is really kind of an enabling and an energizing kind of way of doing business in this new world, if you will. And part of what Jim was saying is it's separating the innovation from the commercialization. If those aren't locked together, what you find, I think, is that the ecosystem, because the innovation isn't locked into one person, one vendor, one person, one entity, you're able to grow that ecosystem. You're able to, amplify everybody's success all at once. And finally, we think that there are also new service architectures. They're beyond just providing the basic internet access, which is what we've done for years and years and years. We think that there are all kinds of new interesting cloud type of applications and opportunities in RCord. So at this point, for the next half, I'm going to hand over the presentation to my colleague, Ali Al-Shabibi.